Every second, our sun sends out light and energy that makes life on Earth possible. But it doesn't always shine with the same intensity. The sun has seasons, not like spring or summer here on Earth, but cycles of activity that rise and fall over about 11 years. At the peak of this cycle, called solar maximum, the sun becomes far more active. It produces more sunspots, more solar flares, and more massive eruptions of plasma known as coronal mass ejections. These events send charged particles racing toward Earth, sometimes creating the spectacular northern lights, but also threatening satellites, GPS, power grids, and even astronauts in space. I'm James, and this is Space Science and TH, where we journey together into the mysteries of the universe. The sun's power is not just a theory. History has given us dramatic reminders of what happens when our star unleashes its full energy, and each of these events has shaped the way scientists, engineers, and even governments think about space weather today. Back in 1859, British astronomer Richard Carrington observed an enormous flash on the sun, what we now know was a massive solar flare. And less than 24 hours later, Earth was struck by one of the most powerful coronal mass ejections in recorded history. Telegraph systems around the world failed, some burst into flames, and operators reported sparks leaping from their equipment. The auroras was so bright that people could read newspapers outdoors at midnight as far south as the Caribbean. At the time, no one fully understood what had happened, but this event, now called the Carrington event, became the starting point for the science of space weather, proving once and for all that the sun could shake Earth's magnetic field and disrupt human technology. Fast forward to March 1989, when another powerful storm struck during a solar maximum. In just 90 seconds, the entire electrical grid of Quebec, Canada, collapsed, plunging 6 million people into darkness for 9 hours on a freezing spring night. Satellite systems reported glitches, transformers overheated, and power companies worldwide realized that solar storms were not just a scientific curiosity, but a real threat to modern infrastructure. This blackout became a wake-up call, prompting utilities to work with space weather forecasters and prepare for future events. More recently, during the so-called Halloween storms of October 2003, a series of record-breaking X-class flares and coronal mass ejections pounded Earth one after another. Radio communications were knocked out for hours, GPS accuracy dropped, dozens of satellites malfunctioned or shut down, and astronauts aboard the International Space Station took shelter in heavily shielded sections of the station. Meanwhile, the night sky exploded in color, with auroras seen as far south as Texas and Italy, thrilling millions of people who had never seen them before. These storms were a turning point for space agencies, who invested in better forecasting models and procedures to protect spacecraft and crews before storms strike. Each of these events tells the same story. The sun can disrupt our world, but it can also inspire awe, push science forward, and motivate us to build better systems that keep society running even when the sky above is storming. Right now, we are in solar cycle 25, the 25th cycle since scientists began recording them back in 1755. And here's the exciting part. This cycle is turning out to be much stronger than expected. When solar cycle 25 began in late 2019, many experts predicted it would be a quiet one, perhaps as weak as solar cycle 24, which was relatively calm. But the sun surprised us. Over the last 2 years, sunspot counts have been consistently higher than forecasts, with solar flares erupting more often and auroras visible much farther south than usual, sometimes dazzling skies over Texas, Spain, and even parts of Australia. NASA and NOAA's space weather teams now say we're approaching a solar maximum earlier than expected, likely between mid-2024 and early 2026, and with greater intensity. This means the coming months could bring more frequent geomagnetic storms and some of the most spectacular aurora displays of our lifetimes. But it's not just about pretty lights. A powerful solar storm has the potential to interfere with satellites, disrupt radio communication, and, in extreme cases, cause blackouts on Earth. That's why scientists are closely tracking the sun every day, using the spacecraft like SOHO, SDO, and Parker Solar Probe to monitor sunspots and a solar wind in real time. This careful monitoring allows agencies to issue early warnings so that power companies, airlines, and even astronauts on the International Space Station can take protective measures when a solar storm is on the way. When the sun becomes more active, Earth feels the effects, sometimes in breathtaking ways, sometimes in ways that can cause real trouble. The most beautiful effect is, of course, the aurora, the northern and southern lights. When charged particles from the sun collide with Earth's magnetic field, they excite atoms high in the atmosphere, creating glowing curtains of green, red, and purple light. During a solar maximum, these auroras can be seen much farther from the poles, turning night skies into natural light shows for millions of people. But there's a serious side to this beauty. A strong solar flare or coronal mass ejection, CME, can disturb the magnetic field around Earth, an event called a geomagnetic storm. These storms can disrupt GPS signal and radio communications, affect flights that rely on polar routes, increase radiation exposure for astronauts and airline crews, damage satellites, sometimes permanently. In rare cases, overload electrical grids, like the famous 1989 storm that caused a massive blackout in Quebec, Canada. With modern society relying so heavily on satellites for weather forecasting, communications, and navigation, a truly powerful solar storm could have global impacts. That's why scientists compare these storms to hurricanes, natural events we cannot stop, but we can prepare for. And as we move deeper into solar cycle 25, the likelihood of these intense storms increases. Fortunately, we are not just sitting and waiting for the sun to surprise us. Around the clock, NASA and its partners are watching our star with some of the most advanced space observatories ever built. One of the most ambitious missions is the Parker Solar Probe. Launched in 2018, this spacecraft is literally flying closer to the sun than any probe in history, diving through the sun's outer atmosphere, the corona, to measure magnetic fields, plasma, and the solar wind right at the source. Every orbit takes Parker closer, giving scientists data that was once impossible to collect. Then there's the Solar Dynamics Observatory, SDO, which provides breathtaking high-resolution images of the sun 24/7, letting scientists track sunspots and flares in real time. ESA and NASA are also collaborating on Solar Orbiter, which offers a completely new perspective by observing the sun's poles, a region crucial for understanding how the solar magnetic field flips every cycle. All this data feeds into NOAA's Space Weather Prediction Center, which issues warnings much like a hurricane forecast, giving power companies, airlines, and satellite operators time to protect their equipment. These missions are not just about a science, they are about protecting our technology, our power grids, and the astronauts living and working aboard the International Space Station. The sun may be unpredictable, but thanks to decades of research, scientists can now give us hours, sometimes even days, of warning before a major solar storm hits Earth. When a powerful flare or coronal mass ejection is detected, space weather centers spring into action. Alerts go out to satellite operators, who can put a spacecraft into safe mode to protect sensitive electronics. Airlines receive updates and can reroute polar flights to avoid regions of high radiation. Power grid managers get advance notice to adjust the load and prevent transformer damage. For the rest of us, the advice is simple. Stay informed. Just as we check the weather forecast before a trip, we can check space weather alerts from NOAA's Space Weather Prediction Center or NASA's social media updates. If a big storm is coming, we might get a rare chance to see auroras, or we might be asked to unplug sensitive equipment just as a precaution. What's exciting is how this research doesn't just protect us, it helps us explore. The same models that predict solar storms also predict astronauts headed to the moon and Mars. By understanding the sun better, we make spaceflight safer for the next generation of explorers. And here's the best part. Solar maximum won't last forever. By the early 2030s, the sun will calm down again, beginning its next cycle. Until then, we have a front row seat to one of nature's most powerful performances. And scientists are using every flare, every sunspot, every storm as a chance to learn. The sun is not just a distant ball of fire. It is the beating heart of our solar system, shaping our climate, guiding our days, and occasionally reminding us of its power with brilliant auroras and roaring storms. Right now, we are living through one of the most active moments of solar cycle 25. For scientists, this is a golden era of discovery. Every eruption teaches us something new about how stars work. For the rest of us, it's a chance to look up, to marvel at the night sky glowing in colors we might never have seen before, and to feel our connection to the universe in a way that is both humbling and inspiring. So the next time you hear about a solar flare or a geomagnetic storm, don't just think of it as space weather. Think of it as a reminder that we live under a dynamic living star and that we have the technology and knowledge to both enjoy its beauty and protect ourselves from its power. Thank you for joining me on this journey through the solar maximum. If you found this fascinating, consider subscribing to the channel so you don't miss the next big story.